And now, give me 5, little guy. Woohoo! Awesome. Um, the step 5 is to merge the genotype files across the chromosomes. So merge those into one set of files. So we're going to be merging those bed files, the bed, the BIM, and the FAM files into one across those chromosomes that we have. So just one set of files. It'll make things easier for us. So now what we're going to do in step 5 is we're going to merge all these files, all these bed files into one, all these BIM files into one, all these FAM files into one. So we just have one file across these chromosomes. So we're going to use the plink2 command again. And in this case, what I'm going to show you is how we're going to do that. So we've got these different files here. We've got the BIM, BED, and FAM, 4 for each of the 11 chromosomes. So we're going to go to step 5, merge all bed files.sh here. So what we're going to do is we're going to run this command over here, and we're going to go into this input folder, which I'm showing you is the extracted genotypes bed with all of these files over here. Oh, wait, no, gosh, what happened? Okay, we're going to go in here, all of these, and then ultimately we're going to create a final folder that's going to be called merged genotypes. And you see that right now it does not exist, but this is going to be the output folder. And we are going to tell this here, this destination to the DNA Nexus command is going to say that we want our output. Whatever is the out name, whatever is being saved here, the out name is going to be all chromosome SNPs merged, this PGS ID here, this name of the PGS00053 and the genome build GRCH37. And again, this is just my naming convention to make sense for me, just to know what genome we're using and why, and like what's the ID. You can use whatever you'd like. This is just for me. We're all different. So again, just see that. Then what we're going to see over here is that the out name is going to be over here. And that will be over here, but it's going to be found in this folder. So we're going to have an out name that will be the bad BIM FAM files here. And we're going to be having this SNP here. So let's see all these things here. Now let's run this. So let me just go all the way down here. So ls again, just for reference, so bash step 5, merge all bad files.sh. So it submitted a merge job for all chromosomes. So just one job. So this is the ID here, so we can track it. Let's track the little guy. Just one job here. New plink merge. So this is the same. This J2F. This thing is the same as this over here. So we can just see what this command is doing over here. And what we will notice is that it is essentially hunting. It's finding the list of chromosomes and file names inside. That's what this is doing. It's trying to find the name, and it's creating a folder that's a file that's called merge file paths name, which I'll explain. And then we're going to be merging all of those files that are in the file merge file paths name together and make the bed. So this is the merging command to merge all of them together. And yay, that happened pretty quickly. I think. Let's just see where that one is. We find the merged genotypes has been created already. I'm going to go back to the monitor and just going to do the past hour just to make it simple to find this. And we're going to see that it executed and it's done. If it failed, we'd see the red. And believe me, I have seen many, many, many fails on the process. So I'm trying to make it so that hopefully you can learn from some of my trials, errors, and tribulations. So hopefully you won't find that red fail as much as I did, as many times as I did. So what we will see here is that we get these output files here, show all inputs. So let's just see here, we have the bed files to merge. This step 5 file, that's what we had mentioned we want it to be created. It's creating this here. And that's what this is here. It's in the merge genotypes. And it's telling that this is what we need to merge. It's, for the merged list command in Blink, we need to give it a list of the prefixes of the files that we want to merge. And what you'll notice is that in the extracted genotypes bed, that these were all the prefixes for the different files. So whether it's a BIM, bed, or FAM, it all had the same prefix here. They all were given the same prefix. Oh, wait, let me just undo that here. So like, for instance, this just all has the same prefix. And like, these all have like the same prefix and so on for chromosome 14 and so on. But you can see, and also this one too, I forgot, these above here, they're all part of the same one. And this log as well, but it's just a log file. But you can see they all have the same prefix. And what we were mentioning here to this is we're kind of telling it that it's in the extracted genotypes bed, these files. And these are the prefixes. Remember, these are the prefixes. They're just the stems are all the same. The endings are different, right? BIM, bed, FAM. But the same thing is the same for like chromosome 18 RSIDs. What we'll see here is that chromosome 18 RSID is the same thing here, and it's found here. This is mounting this project. I know it's a bit confusing. Like sometimes you're wondering, well, why is it mount project and so on? And that's also part of what I'm trying to help with is like for my trial and error, like what I got to help with the DNA nexus commands to run because I was like, why is it a mount project or why is it this, why it's that? And it's still stuff that I'm learning and figuring out, and I appreciate all of your advice and help here. But that's one of the things that also is a bit confusing. Like sometimes we just give Sanya tutorials extracted genotypes bed as for it. Sometimes that's all we're giving. And then other times we're giving Mount Project Sanya tutorials extracted genotypes bed. But that's sort of like what we are putting into this text file, and then that is what the plink command is reading. That's what it's reading here. This is what that command is. And then it creates the corresponding files for all of these chromosomes. We have this log file here where it's kind of going through and it's merging them. And what it tells us is 21 variants loaded from BIM file. And what our score file had was 21 variants. So we have recovered all of the 21 variants that we were wanting. If you remember, in our score file, we have a number of variants, 21. These were the 21 variants. So we've recovered these 21 variants. And it's merging this here and it's writing them to this bed file, BIM, and FAM file over here. So what we can observe here is that in the BIM file, we'll see all the variants and we will see all of these 21 variants that we were wanting. And then we will see in the FAM file details about each of the samples. And again, mine will be different from yours, my numbers. And just this is the information here. And it just sometimes just gives a head so it doesn't display all the information. So what you observe over here is that for the BIM file here, for instance, we take this and I'll trash him into this little guy here. And we have all the 21 variants. I know it looks a little confusing because you may not see that some rows are duplicated with some variants, but you see here, these are all the 21 variants for our score file, and we've recovered them here. So now what we have is we have this folder of merged genotypes. We have our FAM, log. We have all the files that we've merged. This is just what we were using internally for this process. We have our bed, our BIM, and other information here. And so this is what we will be using going forward into the PGSC calculator. But now we've finished step 5. High five, little guy. Woo! Awesome. So what this is going to do, this is the step 5 merge all bed files command, the bash script. So it uses DNA Nexus to run the merge job remotely. So running it on the DNA Nexus platform here. And you see here, the Swiss Army knife is the DX app for running arbitrary shell commands, all the ones of interest here, like the Blink ones. So this ICMD one, here this Blink merge command, it passes the Blink merge pipeline command here, this one that we've run. It's been passed in here. This tag is going to attach a tag for tracking, which we can see in the portal. This is going to be one job because we're just merging all the chromosomes. The instance type, again, is going to pick a compute node that has, in this case, 16 CPUs and solid state drive. Priority high ensures faster scheduling. It's slightly more expensive, but it ensures that your job gets pushed to the front of the line. And brief yes means it's a non-interactive submission. You're not going to be interacting, you're just going to be observing. So this script here, so that's the DX one, that's the merge job command on DNA Nexus. But what this script is going to do is it's essentially, in the first part, it's going to be finding all the BIM, .bed, .fam genotype files in our input folder that's mentioned here. Then it's going to build a merge list file for Blink. And then it's going to submit a DNA Nexus job that runs Blink to merge all those files into one binary data set. So just one .bed, one .bim, and one .fam file. And it's going to save the results in the destination in the output folder, where the output folder is going to be Sanya tutorials merged genotypes. That's what it's going to do. So what you see here in the Blink merge command here, this part here, is it's a compound command. So this ls mount project input folder /**bim. I know it's a bit confusing. This is like mounting a project. It's going to list all .bim files, which is a companion to .bed.fam. So they all have the same set of prefixes, as you see. They all have the same set of prefixes. And what it's trying to do is it's trying to list the files. What files are in that folder? What files are in this extracted genotypes bed folder? What are the names? Then what it's going to do is in this part here, after this pipe here, this sed-e, this part here, is going to strip the .bim extension, leaving the base prefix, .bed, .bim, and .fam all share this prefix. So it's just, I could have done this for .fam or .bed, because the .bim, the .bed, and the .fam files, they all have that same prefix. It's same output prefix .bim, output prefix .bed, output prefix .fam. They all have the same ending. So I just decided to use .bim. So inside the input folder, inside this folder, just list all the .bim files and get their names. Then from their names, because I'm doing this for all the .bim files, I'm just going to remove the .bim here. I'm stripping that the ending from the end of the file name, and I'm just trying to get everything with the .bim chopped off. If I did this for .fam, I would have put fam in here and to strip the .fam extension. If I did this for .bed, I would have put bed in here to strip the .bed extension. I just want the part before the ending because all of those three types of files, they have the same beginning, but they're just .bed, .fam, .bim. So that's what this is. And then what I'm doing is I'm getting the list. So you see here that these are actually what those files are. So we had each of these files .bim for this one, the chromosome 11, .bim, .bed, .fam. We have those ones. So this is what we get when I strip the BIM extension. And then I'm redirecting this output into merge file paths name. So that's what I'm redirecting here. This merge file paths name, which Plink needs as a merge list. So I've gone through the folder, I've gotten a list of those files that are in this folder in extracted genotypes bed. I've gotten a list of them and I have gotten them without those endings. So this will be the merge list. This will be telling Plink that these are the set of files that I want to merge together into one BIM, one bed, one FAM file. That's what this merge file paths name is here. This what this is here. And that's when I use the merge list. I'm calling the merge file paths name. I'm calling that. And this merge file paths name is here, bed files to merge. And then I have the PGS ID here, genome build step5.txt. That's what this file is when I finish running it. So then the command will do is in this part, it's going to run Plink with merge list, what I just created. It tells Plink to merge all data sets in that list. So the make bed is going to give the output in binary Plink format, .bed, .bim, .fam. So it's going to be taking the .bed files that were found in that list and combining them into one bed file. All the .bim files in that and putting them into one .bim file. And all the .fam ones and putting them into one. And the .output is going to be the merged output base name. This .out name will say that for those three files, the BIM, BAM, and FAM, the BIM, bed, and FAM files, for those final files that are combined across all the chromosomes, what is the out name? All chromosome SNP merged, then this PGS ID is here, and then the genome build. So it's going to be the names that is going to be the new prefix .bem, new prefix .bed, new prefix .fam. There's a compound command, and you can see here with the semicolon. So we run this bash step 5 merge bed files.sh. This is the job here. You see, this job is the same as this job over here. They're matching. So it says submitted Plink merge job for all chromosomes. The same job ID on the dx command when we do the bash step 5 merge all bed files. That's the same. So we just have this job, this one job running for step 5 because we're just merging up from them for all the chromosomes. So this is the inputs here, and we're telling it what to do. And these are the outputs. So it'll be creating the bed files to merge. GRCH37, the step 5, this is the file that it creates and then it runs it within. And then we have the log file created, we have this file, the bed, the FAM, and the BIM files. That's what are being created. So just the one set, and it's combining them across those chromosomes, those original files. So for those 11 chromosomes, it's created this. So you can see again that these are the bed files to merge that we were using. This is sort of telling it, go find those BIM, those BIM files, the FAM, and the bed files for each of these, and then for the, kind of combine them systematically. So what you can see here is that this is the log file. This is some Star Wars. I'm a Star Wars fan. No need to tell me about your mother. It's all in your logs. So you can see that its options in effect are, make bed, merge list, out all chromosomes. This is the output file. So, it's found so many people, and it's gotten all the 21 variants. In that score file, it has 21 variants for late onset Alzheimer's disease. And this one here has found it. So it's found these 21 variants, and it's written them as the this output name .bed.bim and .fam. 21 variants. So that's what it was doing. So we have one set of output genotype files now. And you see that they all have the same prefixes here. This all the same. Everything before it is all the same. With the fam, the bim, and the bed. And we have the bed files to merge and the log, but we have the genotype information here. So yeah, hooray! So for instance, we can check that our merged BIM file here, this one, it has all the 21 variants here that are needed based on the score file. So you can see them across all the chromosomes, these 11 chromosomes, these 21 variants for the late onset Alzheimer's disease score file for calculating an individual's genetic susceptibility to late onset Alzheimer's disease. So we can see that we've captured all of them in the BIM file, and then we have the FAM file, which has all the sample information that usually stays the same. And then we also have the BED file, which will have the genotype information for these variants for those samples.